All right, well, good morning. I know this talk is probably standing between you and the free coffee when it shows. So, try to stay on track and hopefully through careful coordination with Francisco on a series of conference calls and workshops, this will appear as a integrated series of talks this morning. Focusing, I've been asked to give a little more insight as far as what's going on in California at the local level, and of course, looking at just the coastline here, this is a sea surface temperature map. You can see how there's a lot of regional climate changes, at least with regards to the ocean. The blue implying the cooler waters up in Northern California and the warmer waters to the south. And we all know the dramatic impacts of microclimates, say for example on the growing of grapes up in Napa Valley. And I think we're just learning about how microclimates in the ocean can introduce variability in the ecosystems. And so part of the goals of some of these more regional observing systems are to be able to characterize at a very fine scale, whether it be temperatures, currents, or the sand levels. And I purposely left my name off of this talk because I'm really just a mouthpiece for a lot of the information that I'll be showing here, so I apologize up front if someone isn't acknowledged or the wrong logos show up on the wrong slide here. Southern California, just drilling down here, again you can see some of the scales of variability, how even like places like the Santa Monica Bay, the line here, up in Santa Monica Bay area, you can see temperature variability over scales of kilometers. Drilling down even farther for San Diego, this is a picture after rainfall, and you can see the plumes that come offshore here from Southern California. Has a whole series of wetlands that are important to the local coastal ecosystems, but of course when it rains, you get a lot of the runoff, and those introduce sediment plumes on the coast. Next one, thank you. This is a picture of Imperial Beach. This is one of these large watersheds, lagoon systems inland. After it rains, you get starts to look like chocolate milk off the coast, and of course where this transports, I think Tony talked about 10 billion bacteria within a liter of water. You probably even get more of that after the rainfall, and you get a lot of beach closures that result from that. So there's certainly a lot of drivers for the regional observing systems for California. There's a lot of money spent on tourism. Healthy beaches are, of course, an aspect of that. The ports are, of course, a part of the West Coast economic engine. We have active fisheries management and fishery and very large Navy presence. And from the themes of this workshop that have been the roadshow going around the country, there are, of course, these different regional associations as part of the USIU's program. Southern California, I think, we're very fortunate with the history and degree of detail of observing system capabilities that are already existing here. This is just a snapshot. It looks like you could almost not get your feet wet stepping across these buoys here. But it really shows some of the capabilities that already exist here in Southern California between the CDIP's ocean wave measurement array that they have here in California and actually exists around the country now at varying levels of resolution, a number of glider tracks that are out there, HF radar, and ship surveys. And so I'll try to touch on some of those. Of course, with any ocean observing system, you also need to know the atmospherics, and there's a number of products both from wind modeling as well as aggregating wind observations. The two really go hand in hand when you start looking at how the ocean interacts with the land and the water. You need to know what the atmospheric conditions are doing. It's certainly a two-way coupling. Thinking a few days back about, I was asked to talk about some of the coastal observing and observational assets, and really one of the granddaddies, I think, of the coastal observing here in the West Coast. And one of my colleagues, John McGowan, has led this. I wouldn't say he established it in 1916, but of course he's been involved more than anybody. And this is a program, a manual shore station program of taking temperature and salinity daily at these 18 stations that extend all the way up to the West Coast. Of course, when you start talking about large observational systems, you immediately start talking about data management. And this was state-of-the-art data management back in the day. This has since, fortunately, been painstakingly gone through and QC'd, and now is available through modern networks for people to access. One of the applications of this type of data, and there's myriads of types of data, and this is really an index, and I think in the ocean observing business, there's often we heard about all the children, the El Niños, and the children of El Niño. Indexes related to trying to distill out the complexities of the ocean and coming up with an index is cottage industry, similar to how Fidelity might have 100 different indices of what the market might be doing. This is an index reflective of what the ocean conditions are, and it's really the only, it's an ocean-related index of a 3-year moving average of sea surface temperature measured from the Scripps Pier, and it's really the few indices that are used to manage fisheries. And as the observing systems are maturing, we think there might be more things about the ocean we know than just Scripps Pier temperature, but as from a federally regulated species, Scripps Pier temperature on a daily basis is used to make some of these decisions. Looking again, working from the old to the new, Cal Coffee, Tony already covered that. This is gives you an idea now. Francisco showed the entire Pacific Ocean on a grid. Looking at now scales out to about 380 miles offshore. The Cal Coffee grids have been sampled for the last little bit in excess of 60 years. And of course, this was established in response to the collapse of the sardine fisheries. More modern tools now that have been developed. This is a platform developed here at Scripps by Russ Davis and Dan Rudnick, and it's a spray glider, and there's several different flavors of gliders now that researchers have developed. Instead of taking those ships out and spending lots of money and heartache of being out on a ship every day, making some of these casts, at least for making measurements of temperature, salinity, and velocity, you can now use tools like this where it increases or decreases its ballast or its buoyancy and sinks, and then on its way down it takes advantages of the wings to glide down and up, and it can cover about 3 kilometers over 500 meters. And so through NOAA funding, through the IU's program, and also through state of California funding, 3 lines have been occupied consistent with the Cal Coffee grid since 2006. And if you think about it, since 2006 now we've covered, through the maintenance of these gliders, over 70,000 kilometers traveled. The researchers like to say that's almost twice around the planet, or maybe 10 times between New Jersey and Spain. So it's quite a large distance traveled by these gliders, and various profiles and index that is just starting to be looked at now. This is looking at from line 90 down here to the south, looking at the average temperature measured by those gliders here near the coast, and using the blue line here is the oceanic El Nino index available from NOAA, and looking at developing an index from the glider data representative of temperature at depth along this leg here. They're finding that we are getting these signals of the El Nino in near the coast, and they don't seem to be out of phase. It's expected to take some time from El Nino at the equator to present itself near the coast, but they seem to be finding it here. 2006, of course, we had an El Nino then, and now the El Nino here. So again, some of the utility of these long-term observations, really to start to scratch the surface of how to use them.